Right, so in this video we are looking at problems involving bearings. So we only talk about three-figure bearings, okay? It's possible to talk about compass bearings, which is when you talk about north 20 degrees east or south 50 degrees west or whatever it might be. We only talk in terms of compass bearings, true bearings, which is a three-figure bearing, and we'll talk about how to interpret those. So when we write a three-figure bearing or a true bearing, it's conventional to use 3 digits. So, and then it's also good to follow it with a T, indicating that it's a true bearing. So for example, in the diagram pictured opposite, the bearing from O to A is 070 degrees true. So we write the 0 at the front because we always write it as a three-figure bearing. Sorry, I just skipped over the bit at the top which actually described to you what a bearing is. So bearings indicate the direction of one object from another object. It's really important that whenever you're solving questions or looking at questions involving bearings, it's very clear where you are measuring the bearing from. That's what's really important. That's what you want to look for in your question first. And then you're looking at, okay, how do I get from here to this other place that I'm trying to get to? Now, when we measure a bearing, a true bearing, we are always measuring the angle in a clockwise direction from north. So, as I said before, the bearing from O, so if we are standing at O, I'm just going to get a highlighter here so you can see where I'm pointing. If we're standing at O and facing north, how far clockwise do we have to turn to get to A? That is the bearing from O to A. The other way that could be written is, what is the bearing of A from O? So that's where it's really important that you read the question carefully to find out where are you measuring the bearing from. Okay, looking for the word from. It doesn't necessarily have to be written first. Okay, so in the diagram pictured opposite, the bearing from O to A is 070 degrees true. The bearing from O to B, so standing at O, facing north, and then how far clockwise do I need to turn to get to B? Okay, that will be 70 degrees plus 40 degrees, which will be 110 degrees true. Now, what is the bearing from A to O? Okay, I'm going to get away from the highlighter because it's too big and cumbersome to draw. From A to O. So the key thing is the from. I'm measuring the bearing from A, which means I've got to imagine myself standing at A and facing north. Now, like when we draw maps, our diagrams are always going to be drawn so that north is directly up, okay, vertically up along your page. So this is north, okay. So I'm measuring my bearing from A to O. So I'm standing at A, facing north. How far clockwise do I need to turn in order to get to O? Okay, so this angle is the bearing from A to O, okay? So it's not just this angle in here, all right? So it's always the clockwise angle. So therefore, we need to use a little bit of geometry here, okay? And hopefully you might remember some of these things. So obviously our two north lines are parallel, okay? That means that these two angles in here, the 70 degree and this angle in here, are co-interior angles, which means that they add up to 180 degrees. So this angle here is 110 degrees. Therefore, the bearing, which is the angle around the outside, is going to be 360 degrees minus 110 degrees, and so it'll be 250 degrees. So the bearing from A to O is 250 degrees true. Okay. All right, let's have a look at some examples. A ship leaves port and sails for 70 kilometres on a bearing of 283 degrees true, and then for 20 kilometres on a bearing of 24 degrees. How far north is the ship from the port? Okay, so I like to do a lot of arm flailing and pointing in the classroom here, so this is sort of harder to do on video, but you've got to sort of think about what vague direction is 283 degrees. So let's just, I'm gonna rub this out in a second, but just to give yourself some reference points. If we're measuring a bearing from this central point here, and this is north, and this is east, and this is south, and this is west, think about what those 4 key bearings are, and then where are you going relative to those. So if we were going directly east, that's a bearing of 90 degrees true. Okay. If we were going directly south, that's a bearing of 180 degrees true. If we were going directly west, that would be a bearing of 270 degrees true. And directly north would either be 0 degrees true or 360 degrees true. Okay. So therefore, if we want a bearing of 283 degrees, that's somewhere in this vicinity. So we're heading off out that way first, okay? Then a bearing of 24 degrees, well, that's somewhere out that kind of way. I'm sorry, I need to get the highlighter again. That'll be sort of heading off in that direction. So then the second step will be going off out in that sort of direction. So try and get a sense of vaguely what directions you're going in. Right, let me just delete all that and let's actually draw a specific diagram relative to this problem. Okay, so 283 we sort of said was vaguely northwest, okay? So let's start with that. Alright, so we're going to start here at the port. I'm going to call that P. If this is directly west, okay, so 283 degrees, somewhere out this way, let's say. And we're going out this far for 70 kilometres. Okay, let's mark a point there. So that's 70 kilometres. Alright, then we go on our bearing of 240 degrees. So this was north, that whole angle all the way around there, 283 degrees. Then we're going to a bearing of 24 degrees. So again, facing north and turning clockwise 24 degrees, we're going to be heading out this way, and we don't go as far this way. So we only go 20 kilometres this way. And we want to know how far north is the ship from the port. So this is where the ship is. So it's not asking you for the direct distance between the port and the ship. I marked where the ship is as, and we're just going to call these points A and B. I'm going to call it S. S gets confused with fives. So we don't want to know the direct distance from B to P. We want to know how far north, okay? That's not a very good straight line. How far in that straight vertical direction have we travelled? So we're just going to need to find this total northerly distance. That's what we need to know. How far north are we from the port? Okay, so we really just need to, again, use 2 different right-angled triangles. It's all about identifying your right-angled triangles here. So we're going to use this green right-angled triangle, and we're going to use this orange right-angled triangle up here. And then we should have our 2 heights. So I'm going to call this bit x, and let's call this bit y, and then adding those x and y together will give us our total northerly distance. Okay, let's focus on the green triangle. So the angle in the triangle, so we know the total bearing is 283, but we know from north around to west is 270, so that means this must be an extra 13 degrees in here. And then we've already got the 24 degrees is an angle in the orange triangle. Okay, so let's focus on those 2 triangles. So in the green triangle, x is the opposite side length, opposite 13 degrees, and 70 is the hypotenuse, so we're going to need to use sine. So sine of 13 degrees is equal to x over 70, and so x is equal to 70 times sine of 13 degrees, which is approximately 15 point, now again it should give us some accuracy, so how far, let's say, in kilometres to 2 decimal places, okay, how far in kilometres to 2 decimal places north is the ship from the port. Okay, so this is 15.75 kilometres, sorry, not metres, kilometres. And then in the orange triangle, y is the adjacent side and 20 is the hypotenuse, so we're going to need to use cos. So cos of 24 degrees is adjacent, which is y, over hypotenuse, which is 20, and so y is 20 times cos of 24 degrees, which is approximately, now again, you actually don't need to work out these 2 decimal values here. We're not trying to find x and y. You could straight away just add 70 times sine of 13 plus 20 times cos of 24 to get your final answer. as a decimal value. Okay, so this y value though is 18.27, so as I said, we don't strictly need to know what that is as a decimal because we just need to know the total northerly distance. Oops, sorry. So the total northerly distance is going to be 15.75 kilometres plus 18.27 kilometres. Now again, I'm not going to use those rounded answers, okay? I'm going to use my nice exact answers in my CAS. I'm going to take that number up there and add it together with this number here, and then round our final answer to 2 decimal places, given the correction I made to the question. And so our final answer here is 34.02 kilometres. Okay, number 2. Jeff is 20 metres due north of a tree and Mary is 60 metres due east of the same tree. So due north means directly north. Due east means directly east, okay? If the question in example 1 had been how far is the ship due north of the port, the ship isn't due north of the port, it's not directly north, and so that would have been a meaningless question. So how far north doesn't mean it has to be straight above it, just means in a northerly direction, what is the distance between them? Okay, what's the vertical distance between them? Due north, though, means straight above. Okay, so Jeff is 20 metres due north of a tree, Mary is 60 metres due east of the same tree. What is the bearing to the nearest degree of Mary from Jeff, of Jeff from Mary? Okay, let's be clear about what's happening here. So we have a tree. Let's put the tree here. We've got Jeff, he's due north of the tree. He's 20 metres due north of the tree. Okay, so Jeff is up here, and that's 20 metres. Okay, then we've got Mary, she's due east of the tree. That's out here. And she's further away. She's 60 metres away, out this way. The angle between north and east is a right angle, so there's our right angle triangle. Okay, so we want to be able to think about this right angle triangle as being useful. Okay, now the first question is, what is the bearing to the nearest degree of Mary from Jeff? Now remember I said the from is the most important thing. From Jeff, how do we get to Mary? So from Jeff, imagining I am Jeff, I'm standing here, I am facing north, which is directly up in my diagram, and I'm turning clockwise. How far do I have to turn? So this, I'm going to mark, this is my answer to part A. How far clockwise do I have to turn from Jeff to get to Mary? Okay. The second question is, what is the bearing to the nearest degree of Jeff from Mary? So the from is the important word. From Mary. If I am Mary, standing at Mary, Mary is facing north and she is turning clockwise until she gets to the direction she'll need to go to get to Jeff. Okay, so that purple angle there is the answer to part B. Okay, so we need to use our right angle triangle though to help us with these questions. So we should be able to use the right angle triangle. We've got two lengths to find, let's say for example, this angle up here, and also this angle down here is going to be helpful. Okay, so let's focus on finding theta first. So if we think about theta, that means 60 is the opposite length and 20 is the adjacent. So we need to use tan. So tan of theta is 60 over 20, which is 3, which means that theta is going to be inverse tan of 3, 60 over 20, inverse tan of 3. You could write 60 over 20, that's fine, you don't need to simplify at this point. Oh, sorry, Control Enter for a decimal. So that angle is about 71 point, we only need nearest degree for final answer, so I'll just round this to one decimal place, 71.6 degrees. Actually, we could just use, we can just round to the nearest degree, 72 degrees. And then we can either use tan theta equals 20 over 60 to find alpha, or we can just use the fact that alpha is going to be 180 degrees minus 90 degrees, which is the right angle, and minus theta, which is 72 degrees. Okay, so 180 minus 90 and minus this angle I've just found here. So again, to the nearest degree, that is 18 degrees. Okay, so we've now got that this is 18 and this is 72. Okay, so now we should be able to find the bearings. So the bearing of Mary from Jeff is this orange angle up the top here, and that's going to be 180 degrees minus 72 degrees. So 180 minus 72 should be 108, so the bearing is 108 degrees true from Jeff to Mary. Okay. The purple angle, the answer to part B, the bearing of Jeff from Mary is going to be found by doing 270 degrees all the way around to that horizontal line and then adding on that extra 18 degrees. So this one will be 270 plus that 18 degrees, and so that is 288 degrees true. Okay, so again, really careful about where you're measuring the bearing from. Alright, example 3. A bushwalker sets out from a campsite, which is called A, campsite A, hiking due east for 5 kilometres and then on a bearing of 100 degrees for 3.2 kilometres to reach campsite B. Calculate how far south campsite B is from campsite A and give your answer correct to the nearest metre. Okay, let's have a look at what we've got happening here. So sets out from A, hikes due east till it gets to some point, that's 5 kilometres, and then on a bearing of 100 degrees. Okay, so facing north, turning clockwise for 100 degrees, we're going to go past 90, okay, so we're sort of going to head out down this way for 3.2 kilometres. And then this will be where campsite A is. Calculate how far south campsite B is from campsite A. Okay, so again, thinking about a suitable right-angled triangle. Using the 100 degrees, we can work out that this must be 80 degrees in the triangle. We want to know how far south. That's the length we're trying to find there. How far south is campsite, I labelled campsite B as campsite A. So it's B where we end up. How far south is B from A? So we need to find that distance x. So we can use this purple triangle to do that. 80 degrees, x is the adjacent side, 3.2 is the hypotenuse, so we need cos. Cos of 80 degrees is adjacent over hypotenuse, and so x is going to be 3.2 times cos of 80 degrees. Correct to the nearest metre, 3.2 times cos of 80 degrees. Now, our lengths are all in kilometres here, so this is 0.556 kilometres, which is 556 metres. So again, you can leave it in kilometres as long as you round it to enough accuracy to get it to the nearest metre. So either of these are correct, but you do need 3 decimal places in kilometres if you want your answer to be correct to the nearest metre. Okay, calculate how far west campsite A is from campsite B. Okay, so I'm going to refer back to my diagram I've already drawn in part A. So we want to know how far west is campsite A from campsite B. So we want that total length there. So again, we already know that this bit is 5. So we just want to focus on this bit. Let's call that y. So in the purple triangle again. This time we're going to be doing, we need y and 3.2, so y is opposite the 80 degrees. So we could do sine of 80 degrees is opposite, which is y, over hypotenuse, which is 3.2. And so y is 3.2 times sine of 80 degrees, which is approximately 3.2 times sine of 80. Okay, so that's 3.151 kilometres. Again, answer to the nearest metre, so we need those 3 decimal places. And then the total distance, therefore, the total westerly distance is going to be that value of y plus the 5 kilometres. So that will be 8.151 kilometres, or you could give your answer as 8,151 metres. to the nearest metre. Part C, calculate the bearing of campsite A from campsite B. Okay, I'm just going to draw a new diagram just so that we've got some space. So we went from A, we walked 5 kilometres, then we travelled on a bearing of 100 degrees, down to B. Okay, so this was 100 degrees. We want to know, calculate the bearing of campsite A from campsite B. Okay, so from campsite B, facing north, how far clockwise do we need to turn to get back to campsite A? So that is the angle that we need to find. Alright, so we need to think about what we know here. Let's work out what's going on. So we know the 100 degree bearing. Actually, I'm not sure that the 100 degree bearing is going to be all that helpful, because we really need to think about where are some useful lengths. What I'm instead going to do is think about drawing this due west that we've just found in part B. So we know this total distance here is 8.151 kilometres. Okay. And therefore, so that bearing, sorry, I'm just going to redraw that because that's got confusing now because I've mixed it up. So we're trying to find how to get all the way around to there. So what else do we know? We also know this vertical height is x. We worked that out back in part A. This is, 0.556 kilometres. So we've got two lengths in that purple triangle, so we should be able to find this angle here, which we can then add on to 270 degrees to find the bearing. Okay, so we know that tan of theta is going to be 0.556. Make sure you stick in the same units. Either use both your metres or both your kilometres. 8.151. And so theta is going to be inverse tan of 0.556 over 8.151. Let's put that in our cas. So inverse tan of, now I've got these two numbers sitting in my calculator, this number up here, enter, divided by this number here. It's going to be, we should have went here, let me do that first. So let's do that previous answer plus 5 first. Okay, so now we've got the two answers we need. Inverse tan, we need this number up here divided by this new number I've just worked out there. Okay, and so we find that theta is approximately, now what do we want? Correct to one decimal place, so 3.9 degrees. Okay, and so therefore the bearing to one decimal place is going to be 270 plus that 3.9 degrees. So it's going to be 273.9 degrees true. The bearing of campsite A from campsite B. It's really important, the from. That's where you're standing facing north, turning in a clockwise direction. So we need to turn 273.9 degrees true to get back to A. Okay, last example. Two campers are separately located along a stretch of coastline running north-south. They simultaneously spot a whale off the coastline. From camper A, the whale is located 500 metres away on a bearing of 120 degrees. From camper B, the whale is located 1 kilometre away on a bearing of 25 degrees. Calculate the distance between campers A and B correct to the nearest metre. Okay, so we really need to put a lot of information together here before we can draw this diagram. So let's say this is our coastline running north-south. Okay, so A and B are both on this line somewhere. Let's think about where the whale is. Okay, so the whale might be about here. Yeah, that'll do, I think. Okay, so camper A, the whale is at a bearing of 120 degrees from camper A. So again, let's think about where 120 is. So 120 is going to be, 120 is sort of going to be somewhere, sort of that kind of angle there. So let me just move my whale down slightly. Okay, so let's think about drawing that kind of angle to the whale. Okay, so this is going to be camper A up here to the whale. So that's 120 degrees. And the distance from camper A to the whale, 500 metres. Okay. Now then, camper B, the whale, is 1 kilometre away, so camper B is further from the whale on a bearing of 25 degrees. Okay, so again, thinking about your bearings, 25 degrees is going to be up this kind of way, so camper B is going to be down here somewhere. So that's 25 degrees, okay, and this distance is 1 kilometre. So again, we want to be consistent with units, so either make this 0.5 kilometres, and then you use kilometres for both of them, or you make this one 1,000 metres and then you use metres for both. Okay, but don't jumble things up. Okay, so we want to know the distance between campers A and B. So again, we want to focus on right-angled triangles. So let's split this up into 2 separate right-angled triangles. Think about what we know. Okay, so in this purple triangle, we could find that distance there, because we can use that 120 degrees, that makes that 60 degrees in there, and we've got the 500 metres. And then in this green triangle down the bottom here, again, we've got the 1,000 metres or the 1 kilometre and the 25 degree, and we can find y. And therefore we can add x and y, sorry I haven't marked camper B, he's down here, to find the distance between campers A and B. Okay, so let's focus on the purple triangle. We're finding x, that is the adjacent side to 60 degrees, and 500 metres or 0.5 kilometres is the hypotenuse, so we need cos. So cos of 60 degrees is adjacent over hypotenuse. Now, do I want to work in metres or kilometres? Doesn't really matter, it's up to you. I'll go with metres. Ask for my answer to the nearest metre, but again, that doesn't mean you have to work in metres, you could still work in kilometres. So x is going to be 500 metres times cos of 60. Let's get that, 500 times cos of 60. So that is 250. It's nice, isn't it? Nice and exact, 250 metres. And then in the green triangle, again we need to use cos. Y is the adjacent side and the 1 kilometres is the hypotenuse. So cos of 25 degrees is y over, I'm going to use the same units, we used metres in the last one, so let's use the 1,000 here. And so that means that y equals 1,000 times cos of 25 degrees. 1,000 times cos, cos of 25. Okay, so this is 906.31 metres. Okay, so therefore the distance between A and B is going to be equal to 250 plus 906.31 metres, which is, if I add 250 onto that last calculation I did, to the nearest metre is 1,156 metres, or you could have written that, if you'd worked in kilometres, it would have been 1.156 kilometres. Okay, either is perfectly correct. Okay, again, a couple of questions from the small building understanding exercise, and then moving on to exercise 4D.